So I want you to look at these two word problems. And you are going to, these are problems that you should be able to work. You do not need to copy the problems that are up here for you to read. But what I'm going to want you to do, where's your paper? Totally told you to get paper. So, what we're going to do is I'm going to give you a couple minutes, and I want you to solve both of these problems. Not copy the problems, but try to solve the problems. And then what we're going to do is we're going to try to figure out how these two problems are different. How are they different? So we're going to look at the first problem. It says, for a large order, Mr. Magoo made 3/8 kilograms of fudge in his bakery. He then got 1/6 kilograms from his sister's bakery. If he needs a total of 1 1/2 kilograms, how much more fudge does he need to make? So, I'm not even going to worry about this bottom problem yet. All I want you to do is I want you to look at this top problem. And so, the first thing I'm going to do is I'm going to give you an idea of how to solve this problem. I'm not going to write any numbers in an addition sentence or a subtraction sentence or anything. All I'm going to do is I'm going to give you a bar model. Bar model should sound somewhat familiar because you used to do those. So if I did a visual with a bar model, so with my bar model, we know that he already made 3/8. We know that he got 1/6 from his sister. Do we know this last bit right here?
No.
No. What is the 1 1/2? Where can that go? That's his total. So we know this. So a bar model can help you take your numbers and kind of put them where they might need to go. It's a visual kind of go, okay, what can I do with my numbers? Kind of figure out what I need to do with them, whether add or subtract. So what I want you to do is take what you know. You don't have to draw the bar model. Take what you know using this bar model and try to figure out what goes here. What goes in that question mark square? So I'm going to give you just a couple minutes. Try to solve it. You can even work in your group. Now, that does not mean get one person to solve it and go, yeah, that sounds great. I want you to try to do it on your own. Try to do some on your own first. Marco, try to do some on your own first. Try to do some on your own first. First, I can get that.
You're not adding your multiplying. I told you. Okay, ready? You want top was Alright, I did it. Okay, I got It's 1 and 12. I can do 11. 12. I got 12. 1 is
I know, you totally say
My head hurts.
Okay, so the first thing, the very first thing you should do, combine these.
Oh.
Because he made this, then he got these. 3/8 plus 1/6. Now, 48 is an okay denominator. 24 is way better. 24 is the least common denominator. 48 makes your numbers way too big. So 24. 8 to get to 24. 3. 3 times 3. 9. 6 to get to 24. 1 times 4. So right there is 13/24. This is not finished. If you told me that your answer was 13/24, you're only halfway done. 13/24 only tells me this. It only tells me what he has so far. You're trying to find your missing add-in. When you have a missing add-in, you have to subtract. 1 1/2 minus 13/24. Can I subtract those right now? Why not?
Because
Denominators are different. You've got a 2 and you've got a 24. I can't subtract those. What does my denominator need to be?
12.
But I'm not there yet. You're like put the cart before the horse. Slow down. Slow down. So 24. 2 to 24.
12.
You know I gotta write all my steps down. You know I gotta write them all down. You know I do that. You know I do that. 1 times 12. 12. There's my 12. Are you happy? There it is. So,
Stay on the horn.
12 minus 13. OMG. I had some people telling me that's fun.
Okay, do that.
You cannot subtract 12 minus 13.
Yeah.
It cannot happen. You cannot do it.
So you have to bring down your one and make that two.
This one
Comes down.
You got
and
no
I twin.
has to slice up that pizza.
So it has to be a whole.
It has to become 24. 24. I'm adding it to what I have. It becomes 36. 24. You guys know this stuff. It shouldn't be like, oh my gosh. You know this. Now I can subtract 13. What? 36 minus 13. 23. That is what's left. 23 24. It's an ugly, nasty fraction, but it's still a fraction. Please tell me you got that right.
Sure.
Sure, whatever, Miss Strickland. Do you see where you mess up if you mess up?
Yes.
If you messed up, was it simple addition?
Yes.
Please stop making simple addition mistakes. You should not be making those. Yes, ma'am. Okay, we're using up way too much time. Okay, we're going to have to speed up. We're going to have to go a lot faster because we're not going to get done. So during lunch, Charlie drinks 2 3/4 cups of milk. Allison drinks 3/8 cups of milk. Carmen drinks 1 1/6 cups of milk. How much milk do the 3 students drink? So, if you do a bar model, 2 3/4 goes there. Allison, 3/8. Carmen, 1 1/6. So what are we trying to find?
And you're trying to add like what they had in total.
So you're trying to find the total. So what are you going to do to solve this?
So
Add. You're trying to add all 3. Okay. Okay, so I am giving you 2 minutes. You better get on it. 2 minutes. 2 minutes. 2. 1, 2. 2. Come on.
I got that. It's 3, 1, 4. No, it's 4 times.
oh my bad.
You can't
It's Hey, I'm still getting the same thing, Nokia. Oh, wait.
You can say
Do you get 64? No, it's more. It's
Okay, what is the least common It is 24. 4 times what is 24? 6. 3 times 6 is 18. 8 times what is 24? 3. 3 times 3 is 9. 6 times what is 24? 1 times 4 is 4. So we have 8 plus 19, 18 plus 9, 27, 27 plus 4, 31. So we have 31 over 24. That, I can do it, but I can't leave it. It's improper. So 24
divided by 31. Wait, what?
So
the 4 divided by
31 divided by 24. Goes 1 time. So I have 1 and 7 24. Is this the final answer?
No.
I have my 2 and I have my 1. So I have 2, 1, and 1. 3 and 7, 24.
You have to add your phone number with that.
I did. Oh, sorry. I even pointed it out. I still said 3. Sorry. 4. I went crazy. And my eraser shows not to cooperate. Okay. 3, 2, 1. The talking is too much because you're not bringing it back down. The book needs to go away. I don't care. It shouldn't be out. Okay, so those 2 problems where you were adding 3 fractions and then you had to like subtract, like add 2 fractions and subtract it from 1 fraction is very similar to what we're going to do today. So now we're going to be doing things where there are 4 fractions. So if you can do 2, you can do 3. If you can do 3, you can do 4. But see, the hard part is if you're doing it, if you're making it harder than it needs to be, it's just going to get more difficult. If you're determined not to find the least common denominator, your numbers are going to get huge. And again, you're just setting yourself up to have to simplify. You're setting yourself up to having to simplify. But if you're not doing it right, then there's a problem.
Why would you do more work than you don't want?
So, I want you to look at 2/3. I do want you to write this down, but I don't want you to work it. Plus 1/5 plus 1/3 plus 1 4/5. I want you to write it down. Why are you throwing away that paper? I did not even tell you I would throw it away. Plus 1 4/5. Sometimes when you're adding numbers, have you heard me sometimes say that when I'm adding things, I look for number patterns or I look for ways that I can group things to make it easier. If I find ways that I can make 10 or ways that I, if I go, okay, well there's a 5, there's a 5, there's a 5, 5, 10, 15, and I can add them quicker. Have you heard me say that? Maybe.
Yes.
I said it. I don't know if I said it in here, but I said it over there.
You said it in
Okay. Like if I'm adding something and I go, okay, well I know that 7 and 3 is 10, and then I can add the other number in there. So, is there something in this problem here that you see that maybe you can do something to make your work easier? That whole work smarter, not harder. Which I love. Work smarter, not harder. Jamarco, what do you see?
The 2/3 and the 1/3, they still have to both have the same. But if you want the middle to be the same, you can just write the time thing.
Well, there's that. But I'm going to go back to what you said when you've got the 2/3 and the 1/3. And do you see something else? Parker. Oh! There's 1/5 and 1 4/5. And so have you heard me say before that like 2 plus 3 is the same as 3 plus 2? That it doesn't matter what order you add it in, you still get the same answer? Adding, you can move stuff around. Subtracting, not so much. Adding, oh yeah. Because 3 minus 2 is not the same as 2 minus 3. Subtracting, you can't move stuff. Adding, you totally can. So, I'm going to match up my denominators. Why make all of these with a denominator of 15 and give myself more work? I'm going to match up my denominators. So I'm going to do my 2/3. I'm going to bring this 1/3 over here. Okay, write this down. So I'm going to put these two together. I'm going to go ahead and throw some parentheses around there just so I can show you. Please don't give me the answer. I'm going to put parentheses around it so I can show that I'm doing those together. Alton, are you writing this down? Plus sign in the middle, because I'm adding everything. Then I'm going to put my 1/5 and my 1 4/5 together. Those have the same denominator. I'm going to add those together too.
So you can do this on Texas? Real Texas?
Yeah. Okay. So what do you get when you add 2/3 and 1/3?
3/3.
3/3.
One whole.
Which is equal to 1.
One whole.
Okay, it's one whole. It's one whole. It's one whole. One. So it's 1, right? Are you sure? 1. Okay, right. I'm not sure I heard that right. Okay.
Sure.
Sure. Okay. So with 1/5 plus 4/5, what do you get? 5/5. Okay, so you get 1 and 5/5. 1 and 5/5 is 2 wholes. It's not 2/5. It's 2. That's like 1 uncut pizza and 1 pizza that's been cut up, but all the pieces are still there. Are you writing this down?
Yes, ma'am. Yes, ma'am.
This is not staying here all day. So 1 plus 2 is 3. And at any point, did we have to do any common denominator work? No. So we saved ourselves.
That's so simple.
Now, is it always going to work out this way?
No.
Sometimes we'll have different.
Sometimes you're going to have to find a common denominator, but if you can group some stuff up and you only have to find a common denominator for 2 fractions instead of 4 or 5, it's great. Yes, ma'am.
Is this algebra?
No.
I'm just making sure. I thought you had.
No. No. Okay. Okay, so now I'm going to show you one where there's subtracting. So, this was a problem on our last test, and it became an issue this morning, and not really an issue, but it was something that needed to be discussed. So, let me go ahead and write this problem up here, and yes, please copy it down. Because it can be done more than one way. This can be done multiple ways. Yeah, I can go and do a common denominator of 8 and just subtract all the way. I wouldn't do it. It's more work. But, now, no. Okay. Now, one thing that came up is, and I'm not doing any work or anything, I'm just making this up, okay? Say that you decided, and because you can't do this right now, okay, I'm making this up. You hear me? I'm saying I'm making this up. Making this up. Okay. Say you decided to subtract all the way across, and you wanted to subtract 1.5 from 7/8, even though I know you can't do that. I know. I'm just making this up. But say you wanted to subtract here, and then subtract this, like you're going this way. You don't do that. When you're subtracting down the line, you have to go left to right. Order of operations, left to right, because you're subtracting everything from 5 and 7/8. 5 and 7/8 is your big number. Because that became an issue, I noticed, it kind of dawned on me this morning. Why, please put that. It dawned on me this morning why some people missed that one problem on the test. Because they were subtracting, they'd be like, okay, I'm going to subtract these together, and then I'm going to subtract it over here. You can't subtract over here, and then take that total and subtract it from over here. That doesn't work. If you're going to do subtract, you have to go left to right. That's why I don't do it. If I'm going to do something like that, I combine my numbers, then subtract my total. If I'm going to say like, okay, I have $10 to buy at the grocery store, if you have a set amount of money, or if you're at the store, and you're buying this, and you're buying that, and you're buying that, and you're buying that, do they take your money and go, okay, this much minus, 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 minus? Do they do it that way, or do they take all of your things and add as they go?
They
They add. They take a total. Add, and then they subtract it from the big number. They don't take your, how much money do you have? Okay, subtract. They don't do it that way. They take it all up, add it, and then subtract it from the big number. It's easier to take one number, subtract it from the other number, rather than subtract. There's more room for error when you're subtracting and working backwards. So, this going this way is harder. So, first off, obviously, you want to match up your denominators. Obviously. I'm going to work this one with you, okay? So, yes, match up your denominators. So, 5 and 7/8 minus 7/8. We'll put that in parentheses because I want to see what I'm doing. Alton, looking up here, writing it down as you go.
So you have to.
Do what? But I'm still going this way to this way. I'm not like putting this in the front. This number is still in the front. This number, my top number is still first. I didn't put this in the front. You see what I'm saying? I appreciate that you paid attention to what I said. Did you hear what Jamarco said? He said, I thought you said you couldn't move your numbers around. He called me out on what I said. My big number is still in the front. Because 3 minus 2 is not the same as 2 minus 3 because I switched my big number. This number, my big one, is still in the front. I didn't move that. These can still move around back here. Okay?
Okay.
The ones in the back can move around. The one in the front has to stay there. 10, I don't want to write on there because it'll get stuck. So if I had 10, and I subtracted 5, and I subtracted 2, and I had 10, and I subtracted 2, and I subtracted 5. If I had $10, and I spent $5, how much would I have? $5, and I spent $2 more. I would get 3. If I had $10, and I spent $2, how much would I have? $8. What if I spend 5 more? But my big number still stayed in the front. So the big number still has to stay in the front. So, yes, sir. They are. Okay, so I'm still going to be subtracting. Now this is the part where first period they were like, what? Wait, what are you doing? So I'm taking my 1/2 and my 1 1/2. I'm not subtracting them. I'm combining them. Because if I had $10 and I spent $2 and I spent $5, wouldn't I still get $3? Yes, ma'am. Same thing.
So
I just
you get
can't find it. I'm combining it. I'm finding my total, like if I'm at the grocery store. I'm taking these two things, I'm putting them together so it's easier to subtract.
Okay, so you still could just do it that way and minus. Okay.
Please stop saying minus. I'm subtracting. I don't minus them, I subtract. But if I keep this minus sign out here and take my parentheses off and put a minus sign here, then I wouldn't do 1/2 minus 1 1/2. I would have to do 5/8 minus 7/8 minus 1/2 minus 1 1/2, and I would have to go one thing at a time. I have to do common denominators across the board, and it's a pain.
So you just get your whole answer and then you just minus it.
Let me subtract. Watch me do the work. How much easier it is just to do it this way.
Wait, so every time you subtract
Your next thing.
Only because I'm combining these. What's 5 7/8 minus 7/8?
0.
It's 5.
It's 5. Got a whole number right there. 7/8 minus 7/8 is 0, but I still have a 5.
There's a minus there.
Minus.
Subtract.
What's 1/2 plus 1 1/2?
2/2.
Because it's 1 and 2 halves,
Yeah, 3.
which is 2. Number 2. So if I did this and I subtracted across the board, I would have to change this to a denominator of an 8. I would have to change this to a denominator of an 8. And then I would have to subtract all the way across. And it would be a whole lot more work. So it's a lot easier just to combine those two and subtract it from this side. Oh, you don't even have to do that. Yes. Well, I combined those two just because they had the common denominator. But I'm subtracting all of these things from this front number. Does that make sense? Kinda. Okay. I subtracted this one from 5 7/8 because it had the same denominator. If it had a 2, I would have put it over here. I would have combined all of them and then subtracted it from there. Does that make more sense? Yes.
Can you to make it even more easier, can you just add the 7 8 2 and then
No, because I'm subtracting.
I'm going to add them and then subtract those two totals.
Oh. Because then I would have 14/8.
So it will be a lot if you just change from all of them to all of them 8, and then you still have to do 7 to 1, and then if you got 2 to 7, then the 1 again.
So yeah, 5 7/8 minus 1/2 minus 7/8 minus 1 1/2. So if we did where we just subtracted across the board, this would be 4/8 minus 7/8 minus 1 4/8. You have to go left to right. So you're making it a million times harder than it needs to be. So then this would be 5 3/8 minus 7/8 minus 1 4/8. 3 minus 7. You can't do that. So now you just have to do borrowing that. This is now 4 11/8. minus 7/8. See why this is now harder than it used to be when that was super duper easy.
Why the 11?
Because 3 minus 7, you can't do that either. I know.
Why can't it just be 8?
Because this is 8/8 plus 3.
Why would that be just one whole? Oh, you said 8 and it's half a whole.
Plus 3.
Oh.
The steps that I taught you 3 weeks ago.
Oh.
Good. Okay, so then 4 and 4/8 minus 1 and 4/8 equals 3. So all these steps where there's potential for really messing up,
Yeah.
when that
It's so much easier.
was so much easier.
I like that. That's why.
I do.
Give it those cold.
Okay, so I'm going to do one more problem because that's all we have time for. And okay, so you're standing people's way. Still, Madeline can't see. So right here I have 14/3. Yes, I know that they are improper. Yes, we will eventually have to make them mixed. But right now I'm not worried about it. Right now I'm worried that I've got a blank in the middle of my problem. But there is a very simple, easy step that you can do that's really cool that I'm teaching you that I didn't learn until I was in a much higher grade. And it's very easy. So I need to take this, and I need to take this, and I need to move them to the opposite side. To get them from the opposite side, to get them to the opposite side, I basically need to change their operation. If they're adding over here, I need to be subtracting over here. So I leave my blank. So 8 and 11/12 minus, because it's adding over here, so now it's subtracting over here. Minus 9/4. So there's an explanation for why it does that. Because you have to to get it off there, you have to make that 0, so you have to subtract it.
Denominator keeps falling.
Yeah. But so you might want to go ahead and make that a mixed fraction first, because if you're going to multiply that by 4, you're going to get a big funky number. So you might want to go ahead and make that a mixed fraction first before you do it. So 3/14. How many times does 3 go into 14?
No, I'm not talking about that.
How many times does 3 go into 14?
4 times.
4. 4.
3, 4, oh, no, I'm sorry.
So you have 8 and 11/12 minus 4 and 2/3. 4 into 9.
2.
2.
That's 1.
2
and 1/4.
and 1/4.
Oh, yeah.
So you should be able to do the rest. So go ahead and do it. You should be able to do that. Go ahead and do it. Alright. So, common denominator 12. I'm going to leave this one alone. This one would be 12, so then this would be 8. 12, this would be 4. 8. 3. Blah, 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 blah. So, if I look at my fractions, if I have 11 minus 8 minus 3, 11 minus 8 is 3. 3 minus 3 is 0. You would have no fraction left. 8 minus 4 is 4. 4 minus 2 is 2. Wow.